Welcome to 5.5, writing linear equations from a graph. Now, if you recall in 5.4, you were given the equation and you had to graph the line. In this topic, 5.5, you are going to be given the graph and you have to derive an equation from the graph. All right, so that is our objective from today. I will be able to write a linear function from a graph. Okay, now the easiest form to write it in that we're going to start off with is the ever so popular slope-intercept form. First of all, y needs to be isolated, as we remember. If it is, we can identify two key parts of the graph from the equation. The first key component of the graph we can identify is the slope. All right, and that is going to be whatever the coefficient of x is, whatever numbers multiplied to x, or whatever is next to x, all right? And that's going to be our m. So m is going to be the slope. All right, so if I bring an example over here, can you identify what the slope is here? It's our m value, or whatever is next to x, and that is going to be, in this example, positive 1 over 2. All right. The next key part of the graph that we can identify from the equation is the y-intercept, which is going to be our b value. That is whatever is added or subtracted onto the function. Sometimes it's first, sometimes it's second. It could be in a different order, but just make sure you're looking for a constant, a number without the variable. Okay, so b is the y-intercept, or it's the starting point. It's where we start the graph, the initial point we're given, and then we can go from there, graphing the rest with the slope. B is the y-intercept, or the starting point. Okay, now, so in this example, the y-intercept is going to be positive 3, or 0, comma 3, since it is an actual coordinate point on the graph. All right, so when we write a linear function today, we are going to write it in slope-intercept form. Okay? Now, for slope-intercept form, we need two things. All right, we need two key components of the equation. We need the slope, which is next to x, and we need the y-intercept. So the first step would to be identify the slope, or as it is also called, the rate of change. Okay, now remember, in order to do that, we're going to use the change over y over the change over x. And hopefully you've already mastered that, as that was our 5.3 topic, mastering how to identify the rate of change or slope from a graph. Okay. So I'm going to do the change in y first on top, and I'm going to do that in orange. So we're going to look at the 2 points we're given here, and we're going to identify from one point to the other, did it increase or did it decrease? Since this slope, or since this linear function is from left to right increasing, the y values are going up, we know that the slope is positive. Okay, so we're going to go up 1, 2, 3, 4, 5, 6, 7. That was an increase of positive 7. From negative 3 to 4, an increase of 7. Okay. All right, we're going to get the change in x on the bottom. I'm going to do that in purple. And we're going to go from where we left off when we counted the change in y. We're going to go over to the right, 1, 2, 3. So from 0 to 3, that's going to be a change of 3. And that is why our slope is positive. We have a change in y that's positive and a change in x that's positive, which makes our whole linear function increase and slant upwards from left to right. So there's our slope, and we can simply just put that in the function next to x as a coefficient of x. Now remember, we also learned how to find slope from 2 points. So you could use the the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1 to find slope as well. Whatever you're comfortable with. Whatever tool you feel comfortable with is the tool you should use. Okay, next one is to identify the y-intercept. And that is going to be where our linear function here is crossing the y-axis. Now they intersect here at 0, -3. All right, so that is going to be placed in the spot for b. And so we're going to have y equals 7 over 3x minus 3. And what we do is we substitute that into y equals mx plus b, or slope-intercept form, which we've already done. So there's our final answer. The equation that is derived from this linear function is y equals 7 over 3x minus 3. Okay, moving on to the next one. Pause the video if you're still writing that down. Okay, so for this one, we're going to do the same thing. Step 1, we're going to identify the slope. Okay, so that is going to be our change in y over our change in x. Now, looking at the overall picture here, we can see that this linear function is slanting down from left to right. So at the end, we should know that it is going to be a negative slope or negative rate of change. All right, so I'm going to do the change in y here in green. So we're going to count down from 2 points that were given here on the graph. Down 1 and 2, 3, 4, 5. Now, keep in mind that these values are actually going down by 2. So that's one thing you have to be considerate of and make sure you're checking for. So it's actually down 2, 4, 6, 8, 10. So minus 10. All right, that's our change in y right here. And now we're going to go and get our change in x. I'm going to do that in blue. That's going to be over 2. Again, these are going by 2, and then 4, and then 6, and then 8. So that's a change of positive 8. Okay, so as we know, a positive divided by a negative will give us a negative at the end, and that matches the general overall shape of the function. It's slanting down and it's decreasing, and that means we know that our rate of change should be negative. Now we can reduce this fraction a little bit by dividing by 2. Okay, if we do that, we're going to get negative 10 divided by 2 is 5. 8 divided by 2 is 4. And there's our final slope there, negative 5 over 4. Okay, last key component of the equation we need is the y-intercept. That should be pretty easy. That is going to be up here at 0, 6. So our b value is 6. This was our n value up here. This is our b value down here. And now we can substitute that into slope-intercept form. All right. Remember, slope-intercept form is y equals mx plus b. We just found the m. The m is the slope, negative 5 over 4. That goes here as a coefficient next to x. And then we have our b value of 6. And it's positive 6, so plus 6. And there we go. There is our function, y equals negative 5 over 4x plus 6. All right. Moving on. Here we have two unique concepts which we have seen before. In our last topic, 5.4, you did have to graph these horizontal and vertical lines. So hopefully it's nothing of a surprise, but let's go ahead and identify what the equation would be for this. It's not going to be exactly in y equals mx plus b form. So let's identify here what we can. Okay, so we need the slope or our y-intercept or the m value. Now, as you remember, this is a zero slope, okay? We also need the y-intercept, which is our b value. Now, that's going to be -2. It's passing through the y-axis at -2. If I tried to substitute that into slope-intercept form, we would get y equals mx, and m is 0, so 0x, and then plus b, which is -2, so -2. Now, as you can see right here, 0 times x, anything times 0 is 0. So we're just left with y equals -2. And that should match with what we did when we graphed it in 5.4. As you recall, if it's just y equals a number with no x value, it's going to be a horizontal line. All right, that is the opposite scenario of what we have next. As you recall, this is a vertical line. The slope is undefined. So there's nothing we can technically put into y equals mx plus b. We can't put anything in for the slope of m. It's undefined. It's not 0, it's not positive, it's not negative. So as you recall, this one is going to be passing through the x-axis, all right, at 5. Everywhere here on this line, x is 5. And that is just going to be x equals 5, no y value. All right, go ahead and work on the assignment. Let me know if you need any help, and good luck.